Welcome to part 2. We have 2 more examples to go through. This one is definitely a bit of an honors example. There's a lot more going on here, but we get to see how you choosing your fulcrum or your axis of rotation is a super helpful tool for us. So stick with it. You got this. Okay, so the first thing we're going to do here is kind of analyze the forces at play. I have some kind of support force at this end. I have some kind of support force at this end. I have this uniform beam. This CG here, that represents center of gravity. So that's basically, instead of saying that an object has weight spread out over the whole thing, that's kind of hard for us to analyze. We kind of pick this point called the center of gravity. It's not something that we just pick. It depends on the object itself. And we say that weight is all acting through that point. It just simplifies the process for us. So basically what this is they just picked a point and said, hey, for this board, I know that my center of gravity is here, and this is where weight is acting, okay? And then we also have this force over here that would be the weight of this printing press. Okay, so let's think about our givens here. It's been a little while since we've written a givens list. I have weight of the press. They're telling us that the press is 15,000 kilograms. I wanted to figure out what the weight of that is. That's just my mass, so we got to multiply by 10. We're going to get 150,000 newtons. Then I'm going to also have the weight of the beam. They're telling us that the beam is 1,500 kilograms. I'm going to multiply that by 10 to find the weight, and we're going to get the weight of the beam is 15,000 newtons. What we're trying to figure out here is what's FA and what is FB. So what are those two support forces? So let's start by just saying our axis of rotation is point A. I'm going to just pick a point. Now, the reason I chose point A is because if I pick point A, then I can figure out 2 torques that I know, right? I know this weight and I know this weight over here. I have this unknown force over there, but I don't have to worry about the torque produced by the force A, right? Because that is where my axis of rotation is. That's my fulcrum point. So R for FA would just be 0. So I'm choosing this point very specifically because then it lets me kind of not think about that force and calculate my missing force, force B. So we're going to come back over here. We're going to do some calculations. The sum of the torques should always equal A. And right now I'm finding the sum of the torques about point A itself, okay? So I'm going to have a few different torques. The torque of the beam itself, would that one be positive or negative? So this one over here, it's going to be going down and around. That's going to give us something clockwise, so something negative. I'm going to say negative. What would my R value be? Well, from A to that center of gravity point is 10. So negative 10 meters times the weight of the beam we said was 15,000 newtons. Okay, let's take a look at the weight of the printing press. So that torque produced would also be negative. It would also be clockwise. So negative, the distance there would be 10 plus 5, so 15 meters, right? This is my distance from A to the weight force of the printing press itself. And my force is just the weight of the printing press, so 150,000 newtons. The last torque we would have would be FB. That one would be trying to go in a counterclockwise direction, so it'd be positive. R for that torque would be 20, 10 plus 5 plus 5, so plus 20 meters times FB, and I want all of these to equal 0, okay? I'm going to do a little math over here. I'm going to get negative 150,000. I'm going to drop my units if that's okay with you. Bad practice, but it's all right. Over here, we're going to get 2,250,000. Feel free to pause and double check these numbers over here. Plus 20 FB equals 0. All right, we could go ahead and combine those up, move them to the other side. I'm going to get 20 FB equals 2,400,000. If I divide both sides by 20, FB is going to be 120,000 newtons. All right, so we have successfully solved for FB. Now you have some options. To solve for FA, you could pick a different fulcrum, and then you could also sum your torques. Or at this point, I know 3 out of 4 forces, so let me go to my other equilibrium condition, and let me just go ahead and sum the forces. I know that FA and FB are positive. and the two weights are negative. So weight of the press minus weight of the beam, those are all going to equal 0. I'm trying to solve for FA. I know FB is 120,000 newtons. The weight of the press is 150,000 newtons, and the weight of the beam is 15,000 newtons. And that's all going to equal 0. Sorry, I had to draw that on 3 different lines there. So when you do this addition, subtraction, all of that good stuff, we're going to end up getting FA equals 45,000 newtons. All right, and let's think about this again. If the press is closer to the point B, right, is closer to the right of this beam, I feel like it kind of logically makes sense that your support force, FB, that would have to be greater, right? It kind of is compensating for more over there. FA doesn't have to compensate for quite as much, so it's going to be a lighter force, right? So try to, as much as we can, think through these problems logically, what actually is going on here. I have one final example for you all. That's the last thing you have to do today. And this example is going back to that diving board example from the first problem. So a diving board in the first question, it's an example of a cantilever, a uniform beam that extends beyond its supports. There's lots of different things that are cantilevers. Maybe even in this room you could see one or two. I don't know if you're in 220. If you are, even the flag is kind of an example of a cantilever, kind of, sort of. If the mass of the board is 1,200 kilograms, and the force due to gravity acts through the board's center of gravity. So once again, there's that CG, center of gravity. So that's telling us that our weight of the board is 1,200 kilograms times 10 meters per second squared. So that means the weight of the board is going to be 12,000 newtons. They're telling us that this board is 50 meters long. They're giving us some distances there. They're asking us to figure out the directions of FA and FB. And we're going to actually go ahead and solve for FA and FB as well. So once again, your options for a problem like this, you have sum of the forces equals 0. In this case, since I only know 1 out of 3 forces, that's not really going to help me. Maybe I want to get to that one later. So I'm going to start with my second option, which is sum of the torques should be 0. What point do you want to choose? Where do you want your fulcrum to be? So be careful with this. Choose a point through which one of your unknown forces goes. So I am going to go ahead and choose point A over here. If I choose this point, then I can calculate my torques due to force B and due to the weight of the board. I don't have to worry about the torque produced by force A because the R value is 0 over there. Okay, so the torque produced by force B, would that be positive or negative? This force is kind of pulling up and around. Okay, that's counterclockwise. That's going to be positive. So I'm going to have plus my R value, 20, times FB. Don't know what she is, but we'll figure her out. And then the torque produced by the weight of the board, well, that would be going clockwise. So that one's going to be negative. Now this one, careful here. What is your R value? It's not 20, it's not 30. They're telling us that the center of gravity is the middle of the 50-meter board. So our R value would be 25 over there. And then we know that our force here is 12,000. And those should just be equal to 0. Okay, so when I'm solving, I have 20 FB equals, if you multiply these two together, we're going to end up getting 300,000. Divide both sides by 20. FB is going to be positive 15,000 newtons. And the signs work out. We do actually end up just getting a positive number. That means, hey, yeah, this force is drawn correctly. It was drawn upwards. I got a positive number. Yeah, that's good to go. FB is definitely pointing upwards. So if you kind of think back to that think it through problem at the very beginning of the last video, that was one of the questions they were asking. Is FB up or down? Is it greater or less than FA? So now we know it should be up, and we know that its magnitude is 15,000 newtons. Okay, here's the point in time where I now would use the sum of my forces. According to this diagram, we have FA going up, FB going up, and then the weight going down. I want to solve for FA. We're plugging in for FB. When we solve this, we would get FA plus 3,000 equals 0, or FA equals negative 3,000 newtons. So what does this mean for us? It means the magnitude of FA is definitely less than the magnitude of FB. The negative, I'll even write this out. The negative just means we guessed wrong. So our diagram over there, we guessed that FA was going upwards. FA is actually pointing downwards. That's all that negative means. So your support at point A would be pointing downwards, and it would be less than your support at point B, which would be pointing upwards. All right, with that, that's enough of me. Maybe you watch this on 2x speed and you are like a quarter of the way through the block. Cool, love it. Get to work on your homework and then spend the rest of the block working on your lab stuff. You can obviously read that up in the assignment on Classroom. All right, see you on Monday. Tomorrow, we'll see what I give you to do. All right, bye.